Hi everyone, welcome back to Coding Hives. Today we are going to solve one of the most famous problems in programming to find the nth Fibonacci number. Fibonacci is a very common topic, but here is a twist. Instead of solving it with a slow basic recursion, we are going to use dynamic programming. I will explain everything in a way that even a beginner can understand clearly. We will start from scratch, talk about recursion, then dynamic programming, and finally an optimized solution. So by the end of this video, you will be confident enough to solve this problem in interviews or exams. First, let's understand the Fibonacci sequence. It is a series of numbers where each number is a sum of the previous two numbers like this. You can see 0 plus 1 is 1. 1 plus 1 is answer is 2. Next is 1 plus 2 is answer is 3. 2 plus 3 answer is 5 and so on. Okay. So initially this is the first Fibonacci number 0. And the second one is this one 1. The third one is f of 2 plus f of 1, right? 0 plus 1, that is, and so on. You can see here. Okay, now if you are a beginner, your first thought might be, oh, I can just use recursion because Fibonacci is defined recursively, right? So we can solve by recursion using this formula, like f of n is equal to f of n minus 1 plus f of n minus 2, right? But the problem is recursion repeats the same calculation again and again. For example, let's say we want f of 5. It's fifth Fibonacci number. Okay. So here, to get this f of 5, recursion calculates f of 4 and f of 3, right? This two. Now to calculate f of 4, again need to calculate f of 3 and f of 2, right? Now for f of 3, it again need to calculate f of 2 and f of 1, right? So here f of 3 and f of 2 are being calculated multiple times, right? As n grows larger, this repetition like explodes. So the time complexity of this recursion is order of 2 raised to n, which is exponential and very slow. So recursion is simple, but it is inefficient in this case. That is why we are moving to dynamic programming. So what is dynamic programming? It is just a fancy term for storing results of subproblems, so we don't calculate them again and again. I mean, instead of recalculating Fibonacci numbers again and again, we store them in a list or array and reuse them. Okay, this makes the program super fast compared to recursion. So now we will try to write the code and I will explain it. So here the function name is Fibonacci. And here I am passing n. So here nth Fibonacci number we need to return. Clear? So first what we need to do is we need to create a list to store Fibonacci numbers. Okay. So this is my list dp, and here I am going to store the elements initially with a 0, n plus 1. So it will make a list of n elements and initialize it with a 0. Clear? Next, what we need to do is we need some base cases, like we need to check if this n greater than 0, then only we need to continue, right? So if it is greater than 0, first we need to initialize the dp of 1. I mean the second Fibonacci number, that is 1, right? The first one is 0, already we declared here. So we no need to reinitialize like dp of 0 equal to 0. Okay, so dp of 1, I mean the second Fibonacci number is 1. Clear? Now we need to go through a loop to build the sequence for I in a range of, we need to start from 2, right? As we already have 0 and 1, right? That means first two numbers. So we need to start from the second one. So 2 comma then till n. So we can give here n plus 1, right? And we can give like dp of I is equal to dp of I plus 1, sorry, I minus 1 plus dp of I minus 2. Okay. So this will add the previous two numbers. Okay. So we will get a list here. Got it? Now we need to return the nth Fibonacci number, right? So we can simply return dp of that n. Okay. This will return the nth Fibonacci number. Now we will try to call the function like Fibonacci n. Okay. So here we will try to give a print as well. So I will give print. We can give an f string. The nth Fibonacci number. Okay. Now we will run this code. You can see nth Fibonacci number is 55. Here 10th. If I am giving here 1, you can get 1. Okay. Here we are using a single loop from 2 to n. So the time complexity is order of n only. At space complexity, we created an array of size n plus 1 to store all Fibonacci numbers. So the space complexity is order of n. This is already much better than recursion, but we can do it even better. Okay. So that also I will explain here. I mean, we can optimize the space to order of 1. Okay. So the trick is to calculate the next Fibonacci numbers, we only need the last two numbers, right? That means we don't actually need to store the entire array. We can just keep two variables and update them as we go. So this reduces the space complexity from order of n to order of 1. So here I'm writing the same function of Fibonacci. So first here what I'm going to do is I will check, like, if n equal to 0, then we can simply return 0, and if n is equal to 1, then we can simply return 1. Next, here what I'm going to do is, instead of the list, I will make two variables, like previous 2 equal to 0 and previous 1 is equal to 1. Okay, so here this is our f of 0. I mean, this is our f of 0 and this is our f of 1. Okay, got it? And next I will go through a loop like this for I in a range of 2 comma n plus 1. Okay, so this is the loop. We will declare a variable for current. Current is equal to, we can say, previous 1 plus previous 2. Okay, so we will get the sum. Next we will just swap, I mean, like this, previous 2 is equal to previous 1. Okay, and previous 1 is equal to current. Got it? Then we can simply return the previous one, I mean prev 1. Okay, so we will return prev 1. Now we will call the same. I will call, you can see we are getting output as the same. Okay, so only changes, we are not using any list here. We are using two temporary variables and we are just swapping and doing the calculations. Okay, so here this is much simpler and no need to store the whole array. Okay, and here the space complexity is order of 1 only and time complexity is order of n. Okay, so that's it for today's video. Thank you for watching. Have a nice day.